So this lesson is on identifying whether you have linear, exponential, or quadratic equations. So you need to write these notes down. So pause it and write these notes. All right, so linear is going to have an x with no exponent, right? All of these, y equals 5, 5x plus 1, 1/2 x. They all have x's and y's, but there are no exponents. That's how you're going to know it's linear. If it's exponential, the exponent is going to be the x. And it doesn't matter what side of the equal sign it's on. If it's 3 to the x, if it's 5 to the 2x, if it's anything to an x exponent, it's exponential. And a quadratic is going to have an exponent of a 2. If you see an x squared, that's how you know it's quadratic. So I'm going to go through these with you. A, it has an exponent of an x. That means it's an exponential because the exponent is an x. B has an x squared. That means it's a quadratic because it has an x squared. C doesn't have any exponents. If you don't see any exponents, that means it's linear. And then D has an exponent of a 2x. So because it has an exponent of an x, it is also exponential. So I want for you to pause it and I want for you to try these. You don't have to write them down, but I want for you to look at them and see if you would be able to tell if they were linear, quadratic, or exponential. All right, hopefully you tried them. Let's go through them and I'll tell you what the answers are. A is going to be linear because there's no exponents. B is going to be exponential because it has an exponent of an x. C is going to be linear because there's no exponents. D is going to be exponential because it has an exponent of an x. E is also going to be exponential because it has an exponent of a 3x. And F is going to be quadratic because it has an exponent of a 2. All right, so that's how you do equations. Next up is how you tell from a graph. If it's a straight line, it's linear. If it quickly rises or falls, it's going to be exponential. You also need to make sure you know, we're going to talk about the difference between exponential growth and exponential decay. And it's pretty easy. If it goes down, it's exponential decay. If it goes up, like if you had a graph like this, that would be exponential growth. And then a quadratic makes a U. And it could be a U going up, or it could also be a U going down. Both of those are quadratics. So let's look at some graphs. Here we want to figure out if they're linear, quadratic, or exponential. Well, this makes a U, even though it's upside down, so that means it's quadratic. This, if we kind of drew a line through these dots, see it goes down and curves, that means it's going to be exponential. And because it goes down, it's going to be exponential decay. And you're going to have to put that exponential decay. This one makes a straight line, so that means it's linear. This one makes a V, which means it's going to be neither. Okay, if it makes a V, we call that absolute value because value starts with a V. So it's not either of these three. So I want you to pause it and I want you to look at these 8 graphs and see if you can figure out what kind they would be. All right, hopefully you did it. Let's go over the answers. This goes down and curves. So this is going to be exponential. And because it goes down, it is actually exponential decay. This is a straight line, so it's linear. This goes up and curves, so this is exponential growth as it goes up. This is a straight line, so it's linear. This makes a U, so it's a quadratic. Straight line, so it's linear. This one's actually going to be neither because it curves like that, and it's like a squiggle. And this one curves but goes down, so this is exponential, and because it goes down, it's decay, exponential decay. And the last thing we're going to do is figure out how to tell from a table. So again, you need to write this down. Linear, your y's are going to change by the same thing. Exponential, the y's are going to change really quick, and they're going to have a common ratio, and we'll go through how to find the common ratio in a second. And then a quadratic, you could see the same y more than once. And the second difference is going to be the same. So I know that probably makes no sense, but it will. All right, so let's go through this table. We want to find the difference. So look at our y's, and we're going to see what does each one change by. So to get from -2 to 1, we changed by 3. From 1 to 4, we changed by 3. 4 to 7, 3. So each time we're adding 3. to every y. If you add the same thing, then that means it's going to be linear because we added 3 each time. That means it's a linear function. Okay, let's look at this one. Again, we're going to find the differences. So to get from -6 to -6, we did not change any, right? From -6 to -4, we added 2. -4 to 0, we added 4. And 0 to 6, we added 6. So it's not going to be linear. Because look, did I add the same thing? No. I added 0, and then 2, and then 4, and then 6. So it's not linear. Okay? Let's do it again. To get from 0 to 2, we added 2. To get from 2 to 4, we added 2. To get from 4 to 6, we added 2. So because the second time we found the differences, it was the same, that means it is a quadratic. Okay? So if you do it the first time and they're all different, that means it's not linear. You got to do it again. And if the second time you do it, you get the same number, that's how you know it's quadratic. All right, let's look at this one. Look at my y's. See how I'm going from really small decimals to really big numbers? That means I'm going to guess that it is a exponential. But to tell for sure, let me show you how to find the ratio. Let me pull up this calculator. So, what I mean by common ratio is if I take my y's and divide them, I'm going to take 0.08 and divide it by 0.4, and I get 0.2. I'm going to do it again. I'm going to do 0.4. I'm always going to divide by the very next one. So if I do 0.4 divided by 2, look, I got the same thing. So let me divide one more time. Let me do 2 divided by 10. Oh, not 110. 2 divided by 10 is also 0.2. So every time I divided my y's, I got 0.2. That's how you know it's exponential. And then also you're going to have to tell if it's growth or decay. And if it's going up, it's growth. If they go down, it's decay. So because these values are going up, it's going to be an exponential growth. So let's look through these tables. Again, I want to do these with you just to make sure we're good. And then I have some on the next slide you'll try by yourself. So we want to find all these differences. So from 6 to 3, we subtracted 3. 3 to 2, we subtracted 1. 2 to 3, we added 1. 3 to 6, we added 3. So it's definitely not linear. From -3 to -1, we added 2. From -1 to 1, we added 2. From 1 to 3, we added 2. So all those, the second ones were the same. That means it's a quadratic. Here, 16, 8, 4, and 2. Well, let's try it. 16 to 8, we go down by 8. 8 to 4, we go down by 4. 4 to 2, we go down by 2. It's definitely not linear because those are not the same. To get from 8 to 4, we go down by 4. To get from 4 to 2, we go down by 2. Those are not the same, so it's not quadratic. Well, let's check and see if it's exponential. Again, remember we divide. So I'm going to do 16 divided by 8. That gives me 2. Now I'm going to do the 8 and the 4. I'm going to do 8 divided by 4. That gives me 2. I'm going to do my last ones, 4 divided by 2. That also gives me 2. So the common ratio is 2. So this one is exponential. Then I want to look and see, is it growth or is it decay? Well, my y's are going down. So because they're going down, that means it's exponential decay. This one, look, is kind of easy because it gives you the equation it's using. If x is in the exponent, that means it's exponential. And my numbers are going up, so that means it's exponential growth. So pause it, try these 4, and then we'll go over your answers. All right, this first one should be a quadratic. The second one, we're going down by 3 every time. That means it's linear. Or going up by 3, sorry. That means it's linear. This one, we're going up by 5 every time. So this is another linear. This one, if we divided each time, we would get 0.5. This means it's exponential. Because they're going up, it's exponential growth. So go try that worksheet and let me know if you need help.